For loops are the only example of count-controlled iteration we have, and count-controlled iteration repeats a fixed number of times. And we can take very inefficient code like this and make it more efficient using a for loop. This code is inefficient because we're repeating very similar lines of code multiple times, it's wasting storage space, and it makes it harder to maintain. This code is asking for 10 prices and is adding them together into a total. And we can package it better as a for loop. So here is our kind of structure of the for loop in ERL. The previous inefficient code repeated 10 times, and this for loop is going to repeat 10 times. I starts at 0 and it ends at 9. Importantly to point out, ERL, the for loops are inclusive, which is different to Python. So I can put in the input line and this will now repeat 10 times. Now, what else needs to get put in to match the code from before? Well, I want to add these prices to a total. So I need to put that in my for loop. There's one final line missing from this code. Can you think what it is? Well, it's often forgotten about, but if I've got code like this, which is adding a new value to total, I need to make sure before the for loop begins, I've got an original value for total. Another use of for loops is just to print out numerical sequences. So the variable can be different in the for loop. Before it was I, here I've now called it count. Well, we're going to start at 5 and go all the way to 15. Like I say, it's inclusive. By default, for loops add 1 each time it loops, but we can modify that by adding a step to the first line. So a step of 2 is now going to add 2 each time. So let's say we wanted to get this output. What is our for loop going to look like? Well, first of all, count is going to start from 12. What is our last value of count? Well, it should be 0. And what is my step this time? Well, now we're going down. So it's a step of -3.